Hi everyone, welcome to my channel. So today we will be continuing with the chapter Water Efficiency for the LEED Green Associate exam. So without any further delays, we will move on to our lecture series. Well, in this chapter, there are three prerequisites. They are outdoor water use reduction, indoor water use reduction, building level water metering. So we have covered all these three prerequisites in our just previous lecture. Today we will be continuing with the credits. The first credit is outdoor water use reduction. Well, for your Green Associate exam, you need to know more about the concept and intent. But why I am detailing out all this like prerequisites, credit, the requirement, intent, all, because it will help you to understand it more and memorize things more. And also it will help you for the LEED AP exam. So yeah, now we can move on to the first credit for the water efficiency chapter. It is outdoor water use reduction, and you can earn 2 points for this credit, and the intent is same as the prerequisite for this chapter to reduce the outdoor water consumption. Now let's look on to the requirements for this credit. Option 1, same as the prerequisite, outdoor water use reduction. So non-irrigation requirements. Here we need to show that the landscape does not require a permanent irrigation system after a maximum of 2-year establishment period. So here the direction must be achieved through plant species selection and irrigation system efficiency as calculated by Environmental Protection Agency EPA WaterSense water budget tool that we have discussed in our previous lecture. And option 2, there is a small variation from this prerequisite and this credit, that is reduced irrigation percentage. So option 2 says that we need to reduce the project landscape water requirement by at least 50% from the calculated baseline for the site's peak watering month. So for the prerequisite, we need to have a minimum of 30%, but here it is 50% from the calculated baseline. So it's very easy since they are connected. So you just need to remember the 30% for the prerequisites and the 50% for the credit category. Well, if you can reduce up to 50%, this is the minimum criteria for achieving this credit, you can get 1 point. And for additional reduction up to 100%, you can get 2 points except healthcare, and there is no point for healthcare. Well, for the prerequisite, you need to achieve 30% reduction for the outdoor water use, and additional 50% you can get 1 point, and 100% you can get 2 points. So this is how it works. Coming to the next credit, that is indoor water use reduction, and for this credit you can earn up to 6 points. And the intent of this credit is to reduce the indoor potable water consumption and preserve no and low cost potable water resources. For achieving this credit, we need to further reduce the fixture and fitting water use from the calculated baseline in water efficiency prerequisites for indoor water use reduction. Well, for the prerequisite indoor water use reduction, you have to achieve a minimum of 20%, but there is no points awarded for that. But additional reduction up to 20, from 25% to 50%, you can earn up to 6 points. For 25% reduction for indoor water use, you can earn 1 point for building design and construction. For 30% reduction, you can earn 2 points. 35 it's 3, 40% it's 4, 45% 5, and finally for 50% reduction, you can achieve up to 6 points. But when you analyze the table, you can see it varies according to different adaptation. For example, for interior design and construction, you can earn up to 12 points for the 50% reduction of indoor water use. So this is how it's worked. But for green lead green associate exam, you don't need to remember all these things. Just need to remember they are awarding additional like points for additional reductions. Now coming to the next credit, that is cooling tower water use, and you can earn up to 2 points. The intent is to conserve water used for cooling tower makeup while controlling microbes, corrosion and scale in the condenser water system. Before going on to more detail of this credit, we need to know more about cooling tower. Well, a cooling tower is a part of HVAC system and is a heat removal device that uses water to transfer process waste heat into the atmosphere. A cooling tower is a specialized heat exchanger in which air and water are brought into direct contact with each other in order to reduce the water's temperature. As this occurs, a small volume of water is evaporated, which reduces the temperature of the water being circulated through the tower. As the water evaporates, there will be a buildup of unwanted dissolved solids, which result in the removal of unwanted concentrated water to prevent the inefficient scaling in the equipment. So, to prevent this, makeup water must be added to compensate for this blowdown and evaporation. Basically, these credits attempt to maximize the amount of times water can cycle through the system before being removed by blowdown. Now let's look on to the requirement for this credit. To optimize cooling tower cycle, conduct a one-time potable water analysis for cooling towers and evaporative condenser. Measure at least 5 control parameters listed at the table. The table shows the maximum concentration for parameters in condenser water. Parameters include calcium carbonate, total alkalinity, chlorine conductivity, etc. Basically, we need to calculate the number of cooling tower cycle by dividing the maximum allowed concentration of each parameters by the actual concentration level of each parameters found in the table in the potable makeup water. Limit cooling tower cycle to avoid exceeding maximum values for any of these parameters. This table shows the points for cooling tower cycle. For example, if maximum number of cycle achieved without exceeding any filtration level or affecting operation of condenser water system up to maximum of 10 cycle, you can achieve 1 point. If you achieve a minimum 10 cycle by increasing the level of treatment in condenser of makeup water, or achieve the number of cycles for 1 point and use a minimum of 20% of recycled non-potable water, you can earn up to 2 points. The final credit in this category is water metering, and you can earn only 1 point for this credit. So the intent is to support water management and identify opportunities for additional water saving by tracking water consumption. Now let's look on to the requirement for this credit. Install permanent water meters for 2 or more of the following water subsystem as applicable to the project. The LEED listed subsystems are irrigation, indoor pumping fixtures and fittings, and in the next page reclaimed water is there, domestic hot water or other processed water. I'm not explaining all of this subsystem, but let me explain one, and the rest. The concept is same. like for irrigation, meter water systems serves at least 80% of the irrigated landscape area, and it is same as the indoor plumbing fixtures and fitting. Like we need to meter water systems serving at least 80% of the indoor fixtures and fitting. So coming back to irrigation, calculate the percentage of irrigated landscape area served as the total metered irrigated area divided by the total irrigated landscape area. Landscape areas fully covered with xeriscaping or native vegetation that requires no or routine irrigation may be excluded from this calculation. But for the indoor plumbing fixtures, the percentage you need to take is same, 80%, and the fitting should be described in the water efficiency prerequisite for indoor water use reduction, either directly or by deducting all other measured water use from the measured total water consumption of the building and ground. Well, for domestic hot water, here also meter water use for at least 80% of installed domestic water heating capacity. Reclaimed water, regardless of rate, a reclaimed water system with a makeup water connection must also be metered so that the true reclaimed water component can be determined. And for other processed water, here also the percentage is 80% for expected daily water consumption for process purpose and uses such as liquefaction, dishwasher, cloth washes, pools, etc., and all the subsystems using processed water. Well, that's the end of today's lecture. Hope you find it very useful. And if you like the content, please like the video and subscribe to my channel. It will support me a lot. And also tomorrow we start a new chapter on LEED Green Associate exam, that is Energy and Atmosphere. You can provide me with feedbacks on the comment box. So till next video, bye.